Washington. We now move on to the technology presentation. So I would like to invite the presenter, Mr. Teddy Sharon Chandrakumar, the Head of Engineering, SGRE, for the presentation.
Good morning. I would like to thank IWTMA for this opportunity to SGRE to share with you some of the technology and innovation topics that we are currently working on. So I come from this place called Tuticorin, which is in the southernmost part of India, and it is the epitome of energy transition. So on one side we have thermal power plant with a generation capacity of 1000 megawatt, and on the other side we have more than thousands of wind turbines generating electricity. So I think this is a true capture or a true picture of energy transition, and it is very synonymous with today's conference theme, which is wind powering India's energy transition. So moving forward, I would like to give a quick glance of some of these numbers which we already know. India has a renewable energy installed capacity of 201 gigawatt, of which wind has contributed to about 47 gigawatt. The renewable energy accounts for 46% of the total generation capacity, which stands at 452 gigawatt. And right now, the target India has set for itself is 500 gigawatt from non-fossil fuels by 2030. So we are all in a race and we have to run to achieve this. Moving forward, how does SGRE stand in this current picture? So we have in India a total installed capacity of more than 9 gigawatt. And if you look at the current platform that we are offering, it is a 3x megawatt. We have two variants, 3.4 and the 3.6 megawatt variants with different hub heights, which is 127, 133, and very recently we have also launched the 146 meters. So we have sold more than 3 gigawatt in the 3x platform, out of which 1 gigawatt is commissioned to the central utility grid and operational as of now. We've also done exceptionally well in the power performance measurements that we have done this year across 8 wind farms in India with average performances beyond 100%. And when we also look at the operational point of view, we have more than 5 gigawatt of wind fleet under operation and maintenance with SGRE. And we also have some solar that is currently under operations with SGRE. So what is today driving technology and innovation? Since 2018, when the auctions came in, there was a lot of clamor around the tariffs going down. We have dropped on tariffs by up to 50%. And this has basically put the OEMs to think on what innovative ways we can serve the market, which has to be basically a win-win for both the buyers as well as OEMs. So when we looked at different scenarios, there are certain things that we currently do and we offer this across different markets. So one, I would call it flexible rating. So in terms of the product that we have a baseline product of 3.4 megawatt. And then what is it that we do to make it operate at 3.6 megawatt? So we work around different parameters like ambient conditions, electrical performance parameters. We also, based on the DFIG principle of stator and rotor, we are able to modify certain parameters based on which we are able to increase the active power output by 4%. And so we are able to come to 3.6 megawatt. Moving forward, this is a concept about how do we improve power curves based on pitch control. So when we design power curves, it is based on, or when we design wind turbines, it is based on the different classes of wind that is available. And then we also have the S class. So if you look at the S class, it is a specific wind parameter that we take. Like for example, it could be either 7 or 7.1 meter per second. So, but when we look at the wind farms in India, what is the wind speeds that we are currently looking at? It is definitely less than 7, say 6.7 or 6.8 meter per second. So how are we able to utilize this to improve the power curve? So based on certain pitch and controller updates, software modifications, we are able to increase the rotational speed of the rotor, and we are able to gain a little more of the power curve without going beyond the rated power. So when we look at it in AEP terms, we are able to increase up to 0.8% in AEP without modifying the rated power. So when we see these improvements, they are predominantly between say 6 to 10 or 11 meter per second. So we don't cross the rated output. So this is one interesting strategy that we currently do to improve performance of our products across different wind farms in the country. The next interesting thing that I would like to touch upon is a concept called wake adapt. So in India, when we develop and build wind farms, say 1 to 2 years down the line in operation, there are a lot of neighboring wind farms that come up, and so that has a very negative impact on the wake losses of the main wind farm. So what is it that we can do to control, to have a better control of these wake losses? So we follow something called smart control strategies that are effectively designed to minimize these wake losses. Now, how is this done? We follow two strategies. One is yaw steering, which is nothing but a terminology for wake deflection, which means through yaw offset we are able to bend the wake. And then the other one is thrust control for wake mitigation. So this is based on a pitching strategy to reduce the wake effect downwind. So downstream, the wake effect is reduced. So again, no hardware modifications, but through this we are able to bring down the wake losses, and we are also able to see an increase in the AEP from 0.2 to 1.5%. So this is very site specific, and each wind farm will have its own benefits based on these wake adapt strategy. Moving forward, right now in India, one of the key topics is about grid management, how we are able to give these models to CTU for them to look at how the overall picture of these the wind farm is. So it is very critical for the overall grid management. It also is about effective utilization of these models to ensure that nothing untoward happens when the wind farms are in operation. So when we look at certain parameters like how does a wind farm affect the voltage, how does it impact reactive power, frequency, and all those parameters which are very critical to grid performance and effective grid performance. So in SGRE, we have our own in-house team to develop these PSSE and PSCAD models, which have, I can proudly say today that we are one of the first few OEMs whose models have been approved by the CTU and the Central Electricity Authority. So this is something that we do, and this is also from our global expertise that we are able to excel in this area in India. Going forward, we also have something about the weather and energy forecasting, again an in-house built software. This is also one key parameter of input that is given to CTU for better grid management. Now, when we look at these forecasting models, we have short-term, medium-term and long-term weather and marine data forecast. We also have power generation forecasting for wind, solar and hybrid projects. This is very critical when it comes to grid management, because whenever there is excess power coming from renewable energy sources, how does the utility manage power coming from other sources? So these are certain interesting topics and very critical ones from a grid management point of view. So one of the important things that we do here is a 10-day ahead deterministic forecast. So this is something which the utilities rely on to ensure that the demand and supply are perfectly managed. So this is also an offer that we currently do in the market. So now moving to sustainability. Sustainability is one of the key topics in mature markets. We also heard the panel talk about sustainability in the supply chain. So what does SGRE do in terms of sustainability? We have a few options. One is, we also heard about the blades recycling. So we have the SGRE recyclable blades concept, wherein based on the new resin technology, we are able to reuse or recycle blade components. So for example, if you look at the process of recycling, we first decommission the blades, and then it is immersed in a mild acidic solution at elevated temperatures. During this process, we are able to separate glass fiber and resin, and then ultimately we are able to reuse or repurpose glass fiber, resin, wood, and metal that comes from these blades. So these are very innovative ways of recycling and sustainability, especially from a financing point of view. This focuses mainly on environmental, social, and governance point of view. So there's better financing options available when we go for these techniques of recyclable blades. The next one is about greener towers, which is picking up steam in many parts of Europe. So here, what we are able to do is we are able to reduce the environmental impact through better sustainable steel production methodologies. We use less energy intensive steel manufacturing processes. So there are certain numbers that are available, like for example, based on facts, we are able to reduce up to 0.7 ton of carbon equivalent emissions per ton of steel. So that's like a 63% guaranteed carbon reduction in steel plates compared to the conventional steel that is being used. So these are various ways in which we are able to contribute to society in a very sustainable basis. And then the last one I would like to also talk about is the life extension programs. So currently the wind turbines are certified for a design structural life of say 20 years, and now it is also moved to 25 years. So what happens beyond 20 and 25 years? In India, we have this advantage of low wind and high wind season, which we are able to utilize to go beyond 25 years of operation. So in that case, we are able to go to 30 years and in some cases 35 years also, based on site specific conditions. So here what we offer is like we do a detailed load study on the structural and the mechanical components to see the fatigue and the extreme loads for those components if the life can be extended. Then we also have a very proactive preventive maintenance inspection plan, and then we also are able to propose design modifications for these extended operation life, and we are also able to predict the failure rates of these components. So with 10 additional years, say 10 to 15 additional years of revenue, we're able to go up to 35 and 35, 30 and 35 years. So this, I would say, is also a low-cost alternative to repowering. Repowering where you have to completely remove the old wind turbine and put up probably new turbines. So this is like an interim or a stopgap solution for repowering. And these are some of the innovations that we do at SGRE. Apart from that, there are a lot of other things also that we do, but I think I'm out of time, and so I would like to conclude my speech here. So thank you very much again, IWTMA, for this opportunity. Thank you.